I hope you took a good break, enjoyed your coffee and your sweets. Again, it's time for Ben Edmunds. So let's hear it for him. And the subject of his talk is more than just a hammer, expand and integrate beyond PHP. Let's hear it for Ben.
What's up, y'all? Serbia's been really fun. They introduced me to Rakia last night, and so this morning wasn't as fun as last night was. Yeah, so today we're going to talk about more than just a hammer. The idea here is how do you use more than just PHP in your stack? How do you integrate other languages, share data across those languages, and really just choose the best tool for the job? We all love PHP, but it's not always the best choice for everything. Who am I? You already know. Do some open source work, CodeIgniter, PHP Fig, engineer at Wayfair. We'll move on. So what is PHP? PHP is a hammer, but it's sometimes an awkward hammer. And Maslow tells us that if all you have is a hammer, everything looks like a nail. Different projects, they have different needs. So why might you want to use different languages? Maybe what you're solving is not solved well in PHP. Maybe another language has a library for that that's better suited to it. Maybe the certain thing you're doing just isn't a good fit. So maybe you're doing like sockets. PHP is probably not the best use for that. You might want to use something like JavaScript. Maybe you're doing machine learning. You can do it in PHP now, especially with the JIT, but there's not good tooling and libraries and all that available to us for that. You might want to use Python for machine learning. So how do you use these things along with it? Also, for code reuse, maybe there's already something in your org that was written for this, or something you find open source that was written to solve your problem. If it solves the problem, why go rewrite it in PHP just so you're in the same stack as everything else when you could reuse it? And then cross-app communication. So if you have a PHP app here, you have another PHP app or a Python app here, how do you communicate across them? Another reason you might do this is just for team efficiencies. So maybe you join a new team, and that team is very good with Python or another language. You want to be able to reuse your PHP apps here, but not necessarily make the whole team learn PHP or retool all their tooling. You need to be able to stay efficient with what they're good at. And then employee retention. So we're engineers. We like learning new things. We like trying new things. If you're just doing the same thing every day, you're going to get bored and you're probably going to leave. You know, we only stay at most jobs for a few years as engineers. So for the company, expanding to more languages can be a way to retain employees because it keeps things interesting. And then just continuous learning. You know, as an engineer, we need to keep learning. There's patterns you'll see in other languages that you might not see used a lot in PHP, and that will help you write better PHP in the future. Just when you learn those patterns, you see the way things are solved in other languages. There's a lot you can learn from that. All right, so what do we have now? We now have two problems. We have PHP and something else. How should you get started with this? I would say the way you should get started, let's say you want to try a new language, you want to integrate this in your stack, you should get started with a new product, maybe a new module for an existing product, or just a library, some type of small tooling that does something very specific. I wouldn't try to go in and port your app that runs your whole business into something new. You're not going to know the pitfalls and the problems you're going to hit. So just pick off something new that you think is a good fit for this and try it out. Just be curious. Another good place is internal projects or tooling that your developers are already using. We're looking at this now for my team at Wayfair. So I'm on the PHP platforms team, but a lot of other engineers in Wayfair are doing things in Python or Java. So we're looking at, with the tooling we're building some deprecation tooling. Maybe we build some of that in a different language, just so that we can flex those muscles and stay in connection with what engineers the rest of the company are doing. Choose wisely, though. This is something you'll have to support. If you're deploying this in your existing ecosystem, this is something you'll have to have deployment paths for, maybe production support for, things like that. You don't want to be the only engineer on your team that knows how to do something in Ruby, and now the Ruby app's broken at 2 a.m., unless you like getting up at 2 a.m. to fix Ruby. Another reason you might do this is just the feature's not supported well in PHP. We kind of touched on this, but it can get more specific, right? So maybe async support. we had a great talk on fibers, but async support's not fully used in PHP a ton. It will be soon, hopefully, but we're not quite there yet. So if you really need async, maybe use a different language. For example, Python has really great async compatibility via Tornado. Another reason might just be that the experts prefer a different language. So Python, great machine learning. C++ has financial libraries, things like that. So if you're doing something in a specialized field, and the experts in that field are using different tools, you might want to use a different tool for the job. Or if the libraries you're finding in PHP are low quality. I know I've had a lot of issues with web scraping in PHP, and I've solved that with Ruby, because Ruby has some pretty good libraries for that. Yeah, so just, it's all about being able to use the best tool for the job. So let's say I've convinced you should try this, just to expand your horizons a bit. How do you actually go about doing it? So the simplest way is with C, right? So PHP is written in C. We can run C pretty natively with FFI. It's an easy compatibility there. The problem is then you have to write C and all the problems that come along with that. It's not a very high-level language. So you're trading off one set of issues for another. Let's say we want to pick just any language. We want to pick JavaScript. We want to pick Python. We want to pick something we can't run directly. How might we do that? Message queues are a great way to do this. RPC or APIs are also a great way. So queues, a message queue is really just a way to send a message from one process to another or one system to another. So we have a queue somewhere, we're sending messages into that, and then we're consuming messages off that queue. And it's pretty vague on what that has to be. So we can use that for a lot of things. And then RPC, remote procedure calls, there's lots you can do here. There's kind of your traditional RPC API, which a lot of people don't love anymore, but it does have a very exact purpose. You're running a remote procedure on another system. You can use things like a Java bridge, right? So there's more direct communication layers that are RPC, but they're really made for this purpose. Like I want to call this thing in this place. Probably the simplest one that it's definitely where I started in doing this, which is databases. So I'm just going to store a record in a database somewhere, mark it as not done yet, and then my other process will check for that record and then mark it as done when it's over. That's really your most basic queue. And then Redis, it's a pretty simple caching layer. It's in memory. It can give you just a basic pub/sub model. So it's a quick way to do a pub/sub model with Redis. The problem there is retention. So because it's in memory, there's data retention issues. You can store that data off to a database or a persistent store. Then you lose a lot of the performance benefits that you have from Redis. So it's just trade-offs to consider. And then inter-process COM, IPC, and shared memory are another way to accomplish this. So this is usually done on the same server. So you're sharing memory across processes, and you're calling processes across the same server. This is usually your most performant option, but it can also be pretty complex. There's a lot to manage there. You have to store and retrieve data across processes. And then there is the limit of being on the same server. Messages, message queues, sockets, they're technically inter-process communication, but they're more distributed. Yeah, and so this is inherently stateful as well. So because you're running it on the same server, you're sharing the same memory, there's just state inherent in the way you do this. And then semaphores are another way to do this. It gives you exclusive access to resources on your same machine. You can limit that on the processes here, and you can simultaneously use the same resources. So it can be a pretty performant way to handle it. It lets you exchange the data through the processes without overhead, HTTP or socket overhead, anything like that. This is locking and synchronous, though, so you have to watch for that. It's inherently stateful as well. Usually semaphores are just on the same machine. You can actually run this across a cluster, and so Apache Zookeeper is a way to do this. So there are options here if you need the performance benefits. And then direct execution. This is really the most basic one, right? So you're just calling something on the command line, or however you call it. You just call the process and run the thing and pass it through the data it needs. We do that in PHP with exec, shell exec, functions like that. That is inherently stateless because you have to pass in the data you want to use. You're not sharing that data. So I've used this actually pretty successfully in the past. So I had a PHP API that we were serving calculations for an insurance carrier on. So you go to buy an insurance policy, it does calculations on what you should get, and then it returns that via an API to the web portal. At some point, we had rewritten these calculators into JavaScript because we needed to run them directly in the web browser for performance reasons. So if you go to buy this policy, you want to immediately see what it's going to cost you. You maybe want to add something, take something off, and see the cost immediately. And so we had this calculator already written in JavaScript, but now we have this PHP API that needs to return it. And so we needed a way to still reuse the calculator because we didn't want to port all of these calculators into PHP. That has multiple problems, right? It's a time investment, resource cost, and then also you have the problem of how do you keep these two in sync? And so that can be a bad problem if the website says it costs something, but then when you process the order, it costs something else. So the best way to keep it in sync is just to use the same data in both places. So we did this with direct execution. In our PHP API, we just called off to a node script on command line, got the number back, and then threw that into our API response. Pretty simple, but it solved the job. All right, so if you do this with direct execution, you need to be very careful about the way you filter your data. You're giving access directly to your system at that point when you're calling something on the command line. So if you do it, just promise you're going to be very careful with the data you pass in, the way you parse that data, filter it, and pass it through to the command line. Another option is cross-compiling or transpiling. Cross-compiling is where you compile from one language to another, kind of like how C and PHP relate. Another option is transpiling, and that's where you're basically compiling from a similar language to one language as a step. So that's something like how TypeScript goes to JavaScript, then goes to your browser. All right, I'm going to talk about JavaScript a lot in this talk because it's where I've done the most of this. Also, anything that can be written in JavaScript will eventually be written in JavaScript, so it's probably useful for most of us here, especially if we're using the web. Let's talk a little bit about the software architecture concerns here. So there's capacity concerns. There's also capability concerns. So capacity is, what are your current servers capable of? What software do you have installed on these servers? Also, your current team. What capacity does your team have to absorb yet another application and stack to maintain? And then the capabilities of the current team. We touched on that, but you have to really think through, am I the only one supporting this? What's my org's ability to help train people, give people time to adjust, to learn these things? It's a trade-off both ways. And then scaling. So maybe, my network operations team is great at scaling PHP. They've never scaled a Ruby app. If I'm going to throw a Ruby app into the wild in my company, how are we going to scale that if it starts being used a lot? So you want to think through that. You want to have a plan. Also, what are the costs involved? So if I'm going to have to buy whole new servers or spin up new instances somewhere, what's the performance benchmark look for that? Is that going to skew our cost in a good direction or a bad direction? Good direction could be a reason to do this. And then expertise. Not just the expertise currently in your team, but the expertise you could tap. Right? So a lot of companies have consultants for hard problems. Maybe you personally, you have friends you go to when you're stuck on a problem. Do you have resources you could tap for a new language? Time to market. This can go both ways. It's a trade-off. If there's already a solved problem somewhere and you can reuse it, that should enhance your time to market. If you're trying to do something completely new that you don't know how to do at all, that could hurt your time to market. And then redundancy. What kind of redundancies in your org do you have across different systems? And that's could be both good and bad. So like the example before, you're joining a Python team. That team already has a lot of Python knowledge. That could give you a redundancy there for Python. Microservices are just a buzzword right now. They're a good thing to consider for this. So if you're moving towards microservices and you want a small service that does one thing well, you're no longer as constrained by the need for it to work directly with the rest of your application. Now you can kind of choose the right tool just to handle that one niche job and let it run by itself. And then there's other things to consider too as far as operations. How do you think about fault tolerance? error reporting, your tooling around, say, your deployments or even your day-to-day maintenance of your applications. You want to think through all this before you start throwing new systems and languages in the mix. And then there's business reasons to consider, both good and bad. So engineering growth, this can help your engineers personally grow and also help you as an organization grow. Say you're a consultancy and you want to start throwing different systems in the mix. This now gives you more tools to solve the problems and also new ways to market yourself. Employee retention, something we talked on before, but that's always important to businesses, especially right now in the current market. Retention's a big issue. Continuous learning for yourself and for others. And then just new skills. Like, it's always great to be able to throw a new skill in your resume or know that if you encounter a problem in a certain area outside of PHP, you can jump in. Some negatives, though, for the business and for yourself personally, is context switching. There is a cost mentally to going from, I'm doing this one thing and I know everything about it, to, oh, I'm moving from PHP to JavaScript, and, oh, wait, this works async by default in these ways. How do I handle that? So there's a context switch there. And then overhead and hiring. If this thing grows and now we need, half the team needs to be Python experts, that might mean hiring people. And then what's your market in your local area for hiring? So just things to consider. Could also be good. So maybe there's tons of PHP engineers here in Serbia, and if you're a JavaScript company, adding PHP to your stack could help you with hiring. All right, so let's get into some more details of what this actually looks like. So message queues. Some popular queues are RabbitMQ, Beanstalk, Redis, Amazon's SQS. You might have seen that as a cloud option. We're going to walk through some Rabbit examples. For the most part, the queue you use when you're starting out doesn't matter a ton. It will matter more as you get more advanced use cases, as you go to scale it, as you start thinking about what it looks like in your environment and your ecosystem. For our example, we use Rabbit. It's super easy to get started. I'd recommend trying it out. If you already have Redis in your current stack, that could be a good way to try this out too. You can just use that as pub sub. For Rabbit, we're going to use the AMQP wire protocol. You can easily use different servers than Rabbit to still run on that same protocol. So that's one nice thing. So we're using the AMQP library for PHP. And so if we swapped out our server from Rabbit to something like ActiveMQ, the code should still just work. Message queue just gives you the ability to send and receive messages. So we're going to dump a payload into a queue, and then we're going to pull that off and do something with it. RPC and APIs are another option. So in the real world, you end up using a lot of these together, right? So like at Wayfair, we have, if you go on our website and you buy a piece of furniture, you're going to go through our store. That store is mostly in PHP. It's going to process this order, and then it might send it off to, we use Kafka, so it might send it off to a Kafka topic. And then more things happen. Off that topic, another process might pick it up, do some additional processing, maybe send it off for shipment or whatever it's doing. That additional process that pulled it off the Kafka topic might need to call another system via an API to get some data, and then use that data for its processing. Right? So in a full system utilizing these components, you're not usually just using one. You're usually using a wide tool set. So RPC is transport agnostic. The concepts are the same no matter the transport layer you're using. Right? So if you're using sockets or HTTP or however you're doing it. They can also be combined with queues. So you can use like JSON RPC payloads and throw them into your queue. It doesn't have to be just a straight API call. XML RPC and JSON RPC are probably the specs you're going to see the most for this. JSONRPC.org is a good place to check out. And it doesn't have to replace your RESTful API. It can live as a part of your ecosystem, right? So I'm trying to really hammer that you're not choosing one tool to rule them all. These are tools to add to your stack. This is what JSON RPC spec looks like. So it's just a JSON payload with a few unique pieces of data so that you know how to process this data no matter where it's at, right? So this could be a straight API call. This could be thrown into a queue, however you decide to process it. The RESTful APIs is probably something we're all very used to from web dev. This is great for exchanging data across different apps, different systems, different languages even. It's not so great for calling an action, though. So I wouldn't recommend that you have an endpoint in your RESTful API that triggers some action to happen. It's not really what REST is meant to do. All right, let's talk about message queues with RPC. So you can go a bit further and send a callback queue in your message. So that's saying, once you get done with this thing, here's the next queue you're going to use as a callback. So this gives you a lot of flexibility. Here's an example. It's a picture. This is stolen from the RabbitMQ site. So basically, you're taking your request, you're throwing it to a queue, server processes it, and then you go to your callback queue when you're done. And so this can be a loop. And then databases, like we touched on, so this is pretty much the simplest way to handle this. You have some type of timestamp or flag in your database, whether it's not something was processed. The biggest issue here is scaling this to multiple services. What if you need to do 2 things on this one record? Well, now you got to add yet another flag to this. What if you want to scale this and you want to have like 5 consumers running against the thing? Now you have to worry about locking issues and timing issues. PubSub with Redis is also a good option. So you subscribe to notifications or you publish notifications. It's a pretty simple way to do this. Huge advantage of this is that it's pretty much real time. Speed is great with Redis. Like we said, though, if you store it in memory, then you lose a lot of the performance gains. So it's a trade-off. All right, so let's go through an example. I'm going to do 2 examples for you. So does anyone know what YoApp is? Do y'all remember this? Hands? All right, we got like 1 person. So it was like peak boom of the web, whatever, I don't know, 15 years ago, 10 years ago, I don't remember. And it was when people were making just really dumb apps and they were getting tons of investor money somehow. So YoApp was an app where you have your contacts and you click a contact and they get a message that says, yo. And that was the whole app. Like, that's it. That's all it does. And they got, like, millions of dollars. I should look up how much. It's kind of depressing, actually. And so this is what it looked like. So you have your contacts, you press it, and yo. What's that?
They moved to San Francisco, actually, to grow their app.
Oh, yeah. He said they actually moved to San Francisco to grow the app. Were there more features planned? Like, could you say sup? All right, we are going to make this, though, even though I've been mocking it. So the first example we're going to do is direct execution. What would that look like in this context? So if you want to do this later, the slides will be published. I'll throw them up on Twitter, too. So here's the commands. We're just going to make a directory, go into that directory. Then we're going to create a modules directory inside there. So we're going to have a modules validator.js file, and we're going to write our validation logic in one place, and then we're going to reuse it in 3 different places. So we're going to use it in a web app, we're going to use it in a Node CLI, and a PHP CLI. All right, so here's what our validator looks like. We're going to export isValid yo is the name of the function. And then we're just going to see, does our input equal the string yo? If it does, we're going to return true, else we're going to return false. Real world, this would probably be more complex. Probably wasn't for YoApp. But here we're going to create an index.html file. So this is just going to be a basic form where you put in some text, and then we're going to make sure that text says yo. So we have a text field, we have a button, and then we're pulling in 2 scripts. So we're pulling require.js, which just gives us a way to load modules. And that's that exports here. Exports, that's the way require.js wants you to export a module. And then we're going to pull in our actual validation module, or index.json file. So this is what the web page looks like here. Pretty basic. The next thing we're going to do is we're going to add a common JS compatible loader to modules require.js. And then we're going to, sorry, that should be modules validator? We'll see. All right. And then we're going to create and edit that index.json file, or JS file. So we're going to call our validator. So we just require validator is the variable. And then we're going to say isValid yo, and then we're going to get the element by ID on that web page. And so that's our form field. And we're going to run it through the validator. And then we're going to alert on whether or not it passed the validation. So here, we're putting in text, we run it, and it's a good yo. We put in some other text, we run it, and we failed to pass because it didn't say yo. All right, so now let's add that to our node CLI. Same script, we're going to reuse it. So here we have validator equals require modules validator. We're going to say if it is a valid yo, and then we're going to run it through the process args. So this is just the way that you pull in CLI arguments in Node. And then we're just going to console log if it was good, and then we're going to exit 0 for good or process exit 1 for bad. And then we can run this from the CLI. So we just run node validate.js and then the text string, yo, and you can see yo passes and fail is bad. And that is using that same module now across both a UI with JavaScript and a node CLI. That's how we use it in PHP. So we take input. This is from a command line. So we're just parsing our command line arguments. And then we're going to call just an exec command, and it's going to call node. So we kind of got a chain here. And it's going to call that same node validate function, and it's going to pass in the input from the CLI. And then we get a response back in our PHP that was successful or false. All right, and then we can run the PHP, and we see if it's true or false. So does it validate or not, using that same JavaScript module. All right, next up, let's talk about a message queue. 1 second. All right, so we're going to use a few things for this. We're going to use the AMQP library for PHP, and we're going to use the AMQP lib for Node. First thing you need to do is you need to install RabbitMQ. This is how you would do it on a Mac. I have no idea how you do it anywhere else. I'm sure Google does, though. And then you append it to your path, and then you can start the server with RabbitMQ server. Next, you'll just set up the repo. So we're just going to make a directory, Q project, and we're going to cd into that directory. Then we're going to create a composer JSON file. And so we're going to add the PHP AMQP lib library for that. And then we're going to composer install it. And this is what our architecture is going to look like. So we're going to have send notification.php. That's going to send a notification into our RabbitMQ queue. We're going to name that the notifications queue. And then we're going to have a JavaScript file that consumes messages off that queue. And it's a long-running process that keeps looking for new messages. All right, so we're going to live code this. It's probably not a good idea, but let's see what happens, right? All right. Can everyone see that? Good? Cool. All right, so we're going to start with the PHP file. You probably can't see the directory structure, but this is send notification.php. I went ahead and added some of the basics here so that you don't have to watch me type and typo all this. But what we're doing is we're just requiring the composer autoloader. Then we're setting up our includes, so we're just using stream connection and message. Then we're going to create a new connection, and so that's going to be an AMQP stream connection. We're going to connect a local host on a port and guest as our user and password. If we go here to the command line, you can see that I'm running the RabbitMQ server over here. All right, now let's do some stuff. So first off, we have to set up a new channel, and that's going to be connection channel. See, I'm already typoing. And then we're going to use that channel with a queue, actually, queue declare. So this is where we set up our notifications channel. And then there's a bunch of these that could really use some named attributes here, right? And so this is, I don't remember. This is telling it that it's a durable queue, which means that it doesn't delete the queue if it's empty, and it also doesn't delete the item off the queue once you consume it. You have to manually delete the item off the queue. Don't remember what these do either. All right, and then we're going to do, actually, So next up, let's set up our notification. So this is going to be our IO, right? And so we have a IO here. We're going to do a few fields. We're just going to do micro time for the ID, just to give us a semi-unique ID. We'll do a sender ID. We'll just hard code that. We'll do a recipient ID, also hard code that. And then we'll do our message. And guess what the message will be? Yo. All right. I'm cheating too because I have notes over here, so I don't forget what these methods are called. All right, and so our message is a new AMPQ message. To that, we're going to JSON encode our notification. And then we're going to send it. So on our channel, we're going to do a basic publish. And we're going to publish the message to the notification. Wow, that was a typo. To the notifications channel. Right? So let me walk through it again, just make sure I didn't mess anything up. So we have the connection to our local AMP queue. We set up a channel. In that channel, we're going to declare a notifications queue. We're going to build out a notifications object or array. So it has an ID, a sender ID, recipient, and a message. Then we're going to make a new message object, which is JSON encoded notification. And then we're just going to publish that to the notifications queue. All right, let's see if it works. Let's move over here. We're going to do PHP send notification. That's a good sign. So I had this tool set up called RabbitMQ admin. And in this, it's just a CLI tool that you can use to look inside your queues. So we're going to run the admin and see what's in the notifications queue. All right, so it worked. We could send a couple. And then we can see the count increasing for the messages in that queue. All right, but that's not what we want to do, right? We want to actually be able to consume it. So let's move over to our JavaScript file. So in this file, we have the bootstrapping already done. So we're pulling in the library. We have our queue name as notifications. And then we're just setting up a function. And inside that function, we're going to have our connection to our local Rabbit server. Notice I'm using async await here. It's just a little easier than having a whole bunch of callbacks. So we'll use async await throughout this so that we don't have to nest a ton of callbacks. All right, so we have our connection. We're going to set up the channel. It is really hard to go back and forth between PHP and JavaScript because I want to put $signs on everything. All right, so we're going to create the channel. And then we're going to assert that the queue exists. Wow, there we go. And then, okay, so let's go ahead and log that. So, waiting on notification. And let's make this a little fancier. All right, so we set up our channel. We're asserting that the queue exists, and then we're waiting for a notification. So now let's await, and we're going to do channel.consume. So we're going to consume off of that our queue name, and then just a function. We're going to pass in the message to that function. Okay? And then inside this function, we'll have the message object. So we do console.log, and we can say received message. Actually, let's do what the message is. And we'll do message.content to string. So we'll take that and we'll throw it out. And then because we're not automatically deleting the messages, we have to ACK it. And so that's going to acknowledge that we consume that message and then take it off the queue. If we don't do that, we're just going to keep consuming the same message over and over. All right, I think that's it. So let's look at it. We have our connection. We have our channel. We're asserting the queue exists. We're just going to wait here. And then we wait for the channel to consume off the queue, and then when it does, it's going to call this callback. It's going to pass through the message object, and we're going to log that message object to the console, and then we're going to acknowledge the message. All right, let's try this out. Let's go over here. Node, process notifications. All right, so we put 3 on the queue. Now we've got 3 here. The cool part, though, is if we pull this off. Oh, no, where'd it go? Hold on. Well, that didn't work. Nope. Okay. Never mind. Oh, there it is. Okay, cool. All right, so here we have our process notifications running. And so that's just sitting here waiting for new messages to come in. So up here, we can run send notification. And then we can see it come in at the bottom to our JavaScript strip that's consuming. We could even run a few of those. So let's run a bunch at once, and then we can see them come in for our consumer. All right, that worked. Cool. All right, it actually worked out. All right, thanks for putting up with my slow typing and typos. If you're interested in a job at Wayfair, reach out. It'd be cool to work together. And let's do some Q&A.
Q&A time, right? Any questions for Ben? No
Everybody wants beer.
Everything was clear. Thank you, Ben, once again.
Thank you.
Thank you.